And we're going to go into the Q&A now. So if you have any questions, please enter them into the questions panel now, and we can see what Orlen can answer for us. So our first question is, how do different frequencies affect RF circuitry?
That's a very good question. So in the communication system, that transmission signal is capable of generating interference, including, let's say, for instance, think of the amateur radios, or if you're old like I am, those CB days when you'd get interference in on your CB radio. Radio TV stations basically are transmitting signals, interference. The days of the rabbit ears or antennas on your TV would get all kind of snow on your picture and things like that if you were around for those days. And the design flaws such as insufficient filtering, inadequate shielding, or frayed or corroded wires making connections to your equipment. It might not necessarily be your printed circuit board. You're going out into the environment. It's all susceptible to transmitter interference for that. Hope that answers the question.
Thank you. Our next question is, why do you keep traces void of solder mask?
That's a very good one too. The liquid photo imageable is what solder mask material is, and it's a screening process, an epoxy screen that you're actually putting down. It's a polymer type material. It's a coating that you're putting over the signal. And with RF microwave PCBs, while it might provide protection for the circuit, mostly it's ineffective in the final performance, especially if you're in the higher frequencies in there. You're better off, and in all cases, you're better off with gold plating. If you're doing some of these designs, there's spec sheets out there. Let's say, for instance, space military, the IPC 6018 is a spec you should get very familiar with. You'll find that in most cases they're saying no solder mask covering, and there's where we're going with the gold flash plating, and military boards sometimes is a hard gold. Hope that answers the question.
Thank you. How do you determine what type of shield you need for your design?
Yeah, see, that's really not going to be something you can necessarily know. You need to work with your RF engineer, but you need EMC, electromagnetic compatibility tests. So you're going to go into a chamber and you're going to see how much of your product is actually leaking out and what's acceptable range and what isn't. So you go rent basically these chambers. Most people don't own the chambers because of how expensive they are. You rent these chambers and you're going to go in there and you're going to do the actual testing on your electronic or electrical devices. If it emits a large amount of electromagnetic interference, also known as radiation, and these emissions have to be under control. The government controls how much you're allowed to leak out. And your devices continue to function as they're intended, even if you have severe electromagnetic phenomena around you. I've always said a good example of this was one time I was standing in front of my microwave oven heating up some green tea, and I had my phone, and I got some magnetic interference on that. Woke up real time that, okay, my microwave oven is leaking bad. So hope that answers your question.
Thanks. A couple of questions that kind of go off of that. What properties of gold make it preferable?
Depending on really that class product, class 2, class 3 product. Class 3 product, normally everything I've used is hard gold, the expensive stuff. Class 2 products, flash gold, it's not quite as expensive, but it's not that nickel plating and then gold plating on top of that copper. So it's really a matter of the product, again, that class 2, class 3 product you're designing.
Okay. And is there a standard via pad stack used for ground shielding?
Not really a standard. In most cases, again, I like as many poke as many holes in there and get to the ground plane as I can. And I'm not running a lot of current through there, and even if I was, I got so many vias that wouldn't be an issue. So I would go with what the board house, before they charge me a premium, I'd make sure I'm not violating their pad to hole ratio, but I'd go in there and make as small as via as I can and put as many as I could in there. And some systems like ours, you can have a stacked via, so I could go in there and create me a stacked via, and it saves time in this type of stitching. But the software also allows me to go in there and do a flood of the entire shape or the entire board. I can flood, assign what vias I want it to flood with. So it makes really adding the vias easy to do.
Okay, thanks. Let's see, our next question is, when is edge plating necessary?
So I find that mostly, and that's expensive process, and you'll still have some openings. I don't know if you recall the slide that was on there, but when you go back through the video, you can see the slide there. I had an example, a picture of edge plating in there. But edge plating is normally when you've got similar boards within a unit. Now, remember, you can put a fence and you can put a frame over it, but that edge could be emitting signals out of there, so you're plating that edge. But it's normally boards within a unit. I guess one good example might be a black box on airplanes. A lot of military uses the plating on the edge like that. But all the boards that are within that black box for the airplane would probably have, in most cases, if not a metal shield around it, at least edge plating on that.
Okay, thank you. Let's see. What are the influences that determine the type of laminate material needed?
That's a very good question, too. And my first response is you need to work with your board house. You really need to get to know those people. They're going to help you a lot. But RF materials, you know, the FR4 just won't handle the actual signals for the RF. There's materials that Rogers makes. G-Tech, I gotta say G-Tech. I mean, General Electric's been sending me a retirement check for over a year now, so I gotta promote them, right? But anyway, you're really looking at the flammability, the UL94, the IPC 4101A for materials, the arc resistance across that material. An example I remember, this is a unit used for medical, and they wanted to use FR4 because they had to keep costs down, but there was no way to keep that from arcing across those high voltage lines. And we couldn't pass UL whatsoever. The high pot test, we were failing miserably. What I did is I went in there and cut open the board, really opened the moke area, so I cut a slot into it. Well, it couldn't creep across that material because it would have to work its way around that moke I cut in there. So, you know, you can do little things like that. Again, this product, if it failed, it was one of those class 2 products. Oh, this costs a lot of money. You know, we need to fix it, but it's not necessarily a throwaway and just get a new one. So those type of things. But the materials are important, and the major applications really is the RF analog or digital on that. So the product class 1, 2, or 3 again comes into play when it comes to materials.
Thank you. Our next question is how to determine proper via spacing of ground fencing vias.
And that really comes down to your pad to hole ratio and how close to the board house. You don't really want to make that to where it's so perforated that you could actually punch a hole, almost knock the board material out because you've put so many vias so close together that you've perforated that section of the board, especially if your vias are going from top to bottom all the way through the board. So a normal spacing that I would, the closest I think I've ever come down to is a 50 mil spacing on that. And again, I'm using a 10 drill for that 50 mil spacing.
Thank you.
Mm-hmm.
How much separation is needed on parallel traces to maintain sufficient isolation?
I will normally go 3 times the line width. So whatever that line width that you're routing, I'll do 3 times that for my air gap. Air gap would be copper edge to copper edge.
Okay, thanks.
Mm-hmm.
Let's see. Next question is, are you not facing manufacturability, solderability issues using VIA and pad on all component pads?
No, because what they're doing is they're actually plugging that hole. So if you do VIA and pad, they have to come back, and that's why they charge more. It's a process, but they're coming back and they're plugging that hole. By plugging that hole, you're not going to lose any of your solder paste down into that VIA hole.
Okay, thank you.
Mm-hmm. I guess I would. I'm sorry. I guess I would add too. When I do my vias, the tolerance I put on my vias like that. So, like I said, I use a 10 mil drill. So I let the board house have a tolerance of +0, -10. So if they want to plate that shut, I really don't have a problem with plating it shut. You're not soldering anything in there, so it's not really an issue. And if you're doing micro vias, laser cut from 1 to 2, which is a micro via, would be great for RF circuit because you can put so many in there. Again, that hole size is so small, and it's a laser cut in there. So, yeah, I'm not really having any issues that way.
Okay, good to know. Our next question is, are back drilled vias feasible for higher frequency designs, let's say above 30 gigahertz?
Absolutely. So a back drill isn't any different than a blind and buried via. It's just a poor person's blind and buried via is the way I've always joked about it. But it's taking up more real estate. Remember, you're back drilling and knocking that pad out. Now, software, most all CAD softwares now will let you eliminate pads that aren't being used on there. But again, you start that back drill on the bottom side and you're back drilling up in, you've got to knock that pad out on the bottom side. So you are drilling larger than, now you need spacing from any traces that would come close to that hole that you're back drilling out. So it's more of a space than it is anything else. Back drilling works great. Blind and buried vias work great when
Orlen, are you there?
Yes, did you hear me?
You kind of cut out there for a minute.
Okay. And I'm not sure where I cut out. So
about 20 seconds.
So basically, what I was saying is back drilling, I call it the poor person's blind and buried via. So back drilling is no different than a blind and buried via. The only difference is that spacing, extra spacing you need because that back drilling is knocking that pad out. Most CAD systems today will allow you to eliminate unused pads on inner layers, but that outer pad that you got to drill and knock out is still large enough that you've got an oversized drill bit to knock that pad out, and you're drilling back to whatever depth you need to get rid of that antenna. But it's just as accurate and just as effective as blind and buried vias. It's, again, that spacing requirement that you need for that exercise drill. I hope you're still hearing me.
Yeah, we can hear you.
Yeah.
Okay.
Yeah, really, we're trying to take out the plating of that via. That's the conductor
Correct.
you're trying to eliminate. So you got to go oversize of the original to get it all out.
And normally when you go oversized on the bottom pad, you're definitely going to knock that barrel out, that antenna that's coming down there.
Yeah. Awesome. Let's see. What other questions do we have? For pads connected to plane, is it better to connect them thermally or flood them over?
In the RF world, it's a lot better to have pad-to-pad connection. If you could eliminate any traces and you could actually place the component where the pads are actually touching, you're far better off. A lot of times the component doesn't allow that type of placement, but that's ideal on there. So really, if I'm bringing in ground on there, the only thing I'm concerned about is too much heat coming off of that. So your board's normally going through an IR oven. Rarely do I see any RF designs going over a wave anymore. So it's usually a double IR process. And your biggest concern there is a cold solder joint because too much heat is escaping out of that ground plane. But ideally, it would be to have that solid connection. But again, a manufacturing engineer, if you've got them in-house, needs to be your next best friend in designing. And if not, whoever's assembling it, whoever you're going to outsourcing your assembly to, they have a manufacturing engineer. You need to get in contact with them. I'd spent in my career at Jabil Circuits, which is a high volume manufacturer supplier up in Michigan. They have an office also in Florida. I happen to be in the Michigan office. My manufacturing engineers for each line that I had to work with was a great resource for what I could do as far as what kind of temperatures we'd run a temporary board through, check for cold solder joints, decide if we need to open it up, but ideally it's full contact if you can.
Okay, thank you. Kind of have another question along those lines regarding via and pad. How do you solve the unbalanced copper, such as Tombstone Problem, if a small component has via in one pad and just a trace in the other pad?
Very good question. And we worked with an issue, like I said, when I was at Jabil Circuits, and we actually went in and changed the pad. Instead of giving us this nice big rectangle pad, that we kind of did it as almost as an arrowhead type. So that what's happening is you've got more solder pulling there. Although you're plugging that via seems to have some kind of indent. It's not perfectly flat and level, so you are getting a little bit of a paste dropping down into the cavity there of where it was plugged. And that was what we found causing most of the tombstoning. So by changing the shape of the pad without the via, basically less of a pull on there is what we were finding.
Interesting. We have a question that asks, do you put the via in pad at the center of the pad?
Yeah, ideally, I don't see any reason moving it off to the edge. You could, but in most cases, because it's plugged, it doesn't really matter where you put it. I do center of pad because, again, that via is a drilling process. So give them the benefit of the doubt. IPC standard says you can be off so much by drilling. I don't want that amount that they're allowed to be off to be out on the edge of my pad and actually have a breakout out of that pad where the via is. So putting a dead center in most cases will stop any breakouts that could occur and still meet IPC standard.
Yes, of course. Do you have any good books on RF layout off the top of your mind?
I do not, but just at the beginning of this presentation, I saw a great book being announced if you take a class. So I was looking at that thinking, man, I've went years in this business and people just have not created manuals like that. So I thought that was a good improvement for people coming into this field.
Yeah, it's as big as a New York City phone book, I'll tell you.
Yes, a good resource. Let's see.
I do see that we have some question marks in the panel there. I don't know if they've been answered or what, but or if they can even how they can ask them if they haven't already done so in the chat there.
Yeah, if you have a question, go ahead and put it in the chat there, so we can make sure we address your question. We do have another question. It is a little long-winded, so bear with me, Orlen.
Okay.
It's stated that RF traces shall be gold-plated, but gold plating is accompanied with a nickel barrier, electroless nickel immersion gold or ENIG finish. Since RF signal is connected with skin effect, it means that nickel, which has 4 times greater resistivity than copper, could bring loss to conductor. Is it still worth using ENIG? Are there any other finishes that work well for RF?
And again, it depends on the frequency that you're running. So when we go gold plating, we're going for reliability, and we're looking for no corrosion. And obviously, the gold plating is going to give us that. We're not going to have a metal breakdown. So that's really why we kind of head there. And again, I think I stressed that gold plating is on a lot of class 2 products, but just about every class 3 product is the gold plating. That little remote I talked about where I get into my garage door, that's not gold plated, and that's not an issue. And again, that's a throwaway. If it fails, throw it away, I'm going to get a new one. But in this case, it's getting weak because I need to change the battery.
Okay.
Hope that answers the question.
Yeah. Let's see. Our next question is there a way to import or export between Microwave Office and Allegro?
The IFF file, DXF, and I know Cadence since they've purchased. I've been working with a lot of people on both sides of the aisle now that we are going to have it as seamless as we do our simulation tools. So it'll be a direct interface into those products. It's not there yet, but I suspect, I probably shouldn't say this, but I suspect by this year, but there's no guarantees. I can't speak for Cadence.
Okay, thank you. Just making sure I caught all our questions here. Again, feel free to enter them as they come up in your head. And if we missed any, in general, RF signals are preferable to be routed on external layers, right?
Yeah, and the reason for that is we've got our components out there, whether they be copper etched down on your board material or whether you're using the surface mount parts that I suggested. The whole idea of routing them on the outer layers is the not needing the via, not adding that chance that you're going to change vias. You need vias to get to the other layer, and ideally is direct connect. Like I said, pad to pad connection is the most ideal. And not always works out that way, but ideal. And again, it's the product that you're designing to. More forgiving products can have components on both sides, and you can use vias. Okay,
thank you. That board that you have showing right now, do you have multiple layers that you can show?
Sure.
Yes, I'm interested in seeing that.
So here's my top layer. Of course, I got my ground. You're not going to see much there. There's my signal layer. Let's come out in here. Let's turn the bottom off. And what you're seeing is the color code will show you the traces that I'm running in there. And then I'm back to heavy RF circuit. So turning the top on, there's my RF ground flood back in. I notice the question was brought up about spacing. And if I cannot keep 3 times the line width, then I want to get ground in there. So I want to make sure I can pour some ground, get ground back in there, isolate those traces.
Thank you.
That answered the question?
Yeah, thanks for showing that.
Okay.
Well, at this point, I don't see any other questions. If I missed any, we will follow up with you. So, yeah, at this point, oh, hold on, we might have one. Oh, no, that's an old one. Okay, so, yes, I will pass this back over to
Scott.
Yeah, hold on. We have one more question since we have some time.
Okay.
Do you recommend any specific conformal coating material for RF board?
Not really. Of course, you know, in the case of an antenna, you're not want to put conformal coating over that. You need that antenna area open. The same way I wouldn't put any RF ground up underneath that antenna. We need that open up on a board, basically wherever that board may reside that you're wanting that antenna on there. But conformal coating is standard on most military installs. So again, the signals, conformal coating might not be necessary if you're doing those frames and those metal covers over top of them because you're isolating that, and conformal coating wouldn't necessarily be needed because of the metal framing shielding far better than a conformal coating would.
Okay, thank you. All right, now I'll pass it over to Scott for real this time. So.
Okay.
Thank you, Orlen.
Oh, you're quite welcome.